Okay, I got another video for you guys. I built this thing kind of in replication of my previous video. You saw the Tesla coil. This is the same circuit. Well, actually, no, it's not. It's the same circuit as Laser Saber's Joule Ringer 3.0. It's missing the Slayer circuit's resistor from the base to the collector. So, and in fact, this is just a simple ringer. Real simple circuit. You just have one component, which is your transistor. The LEDs indicate whenever it's powered on. Interesting thing is, on the LEDs, you have to make sure that this side, which is your positive side of the LED, is going to the negative side of your transistor, and then the negative of the LED is going to your base. Don't know why, but that's the way it works. Laser Saber's Joule Ringer was a homemade ferrite core transformer, and this is just a simple microwave oven transformer. Works really well. I think the frequencies are a little bit different. Laser Saber's Joule Ringer is probably in the higher frequency range. I've noticed on this, whenever I hook it up to an oscilloscope, it's about 4K or 4,000 hertz. It's not too bad. It gets a little bit of a ringing sound similar to Laser Saber's, but I get some interesting effects whenever I hook up my LED. So on the transformer, this is the high voltage side, and the other part is connected to the transformer right here. You can see a little wire going to it, and it's grounded. So I just hooked up my little alligator clip, and it goes to the positive of my light socket, and then the negative goes around here and goes up to the collector on the transistor. So power in goes through there and then comes out here and goes to that side, and then it causes an oscillation in the secondary. Same circuit as a Slayer or a Joule Ringer. So yeah, we'll start up. I have it right now at 23 volts and at 1 amp, but whenever I power this on, I'm getting some feedback or some kickback into the power supply, so it actually drops the voltage, but you'll notice my amperage, even though it's set at 1 amp, it'll show a different amperage, but it's regulating it, or trying to keep it from regulating. So you can see there the little red light on. It's only showing half an amp, but it's kicking that red light on there, showing that it's actually getting more amperage, and I think that's the feedback circuit. It's kicking back oscillations back into the power supply, and it's trying to regulate it to keep it from killing my power supply, really. So here's the light, super bright. We can actually turn it down, and you'll notice a strange effect. It's almost like it's bucking. It's almost like a strobe light. The circuit is, I don't know what it's doing. It's oscillating really strangely. But I can turn down the voltage, and you can see the amperage is still staying the same. Get it way down. Let's turn it down. It was a homemade strobe light, really. Until you get down to about 3 volts. Then my LEDs are, they're still pretty bright. And it smooths itself out. Now, one way to avoid this, I've discovered, is to hook up a smoothing capacitor, or just a high voltage capacitor. This is a 0.02 microfarads, 15,000 volts. You probably don't need that high of a voltage, but I've noticed that the higher the farad, the better this effect works. So we'll turn this off real quick so I don't shock myself. Connect that to here. Connect this one to the other side. So this is effectively going in between the high voltage supply and the light bulb's power input. Alright, so there's the black wire going into one side of the capacitor, and then we're getting the other side of the capacitor. So if anybody knows anything about a capacitor, you're basically, there's a plate in here, and you don't have a direct line of current. You're just getting the voltage oscillating in the circuit. So we'll turn this back on. We're not getting any light out of this yet, but as we go up, there it comes. No more bucking, no more strobe light effect. And we can turn it up and down. So it smooths out that circuit. We get nice bright light. And at 0.1 amp. So we're not getting that crazy half an amp kickback into the power supply. It drops the amperage down way down there. So 16 volts at 0.1 amps. You guys know how many watts that is? Let's tune it down even more. So there. 10 volts at 0.07 amps. I'm getting some pretty good light. I'm curious to see what kind of output I would get on a solar cell similar to laser sabers. But all I did was add that one little capacitor in the circuit, and it smoothed out the oscillations. No ringing, no strobing, no kickback into my power supply. Everything's running like it should. So it's an interesting little circuit. You guys can experiment with that, change things up, try different adding. I'm going to try to add another capacitor maybe in here, and maybe I can get it down to even more of a lower amperage. Oh, that's pretty low already. But fun stuff, guys. Keep experimenting. See you later. Okay, so I went ahead and hooked up my oscilloscope just so we could see what effects are actually going on here. I reset my power supply to where it's directly in. We can get that strobing effect. I've got my green line is just into the power supply, and then my red channel is just hooked up to the output. So and I've got it coordinated up there as well, so you can see the stats. So here we go, 3 volts. We're getting the strobing effect. Not a whole lot of power here, but when we look at the inputs, you can see I'm getting a massive spike in the initial on circuit of the transistor. It's almost 73 volts there. And then my green line is showing I'm almost 9 volts, sometimes jumping up to 6 volts. So I'm getting a little bit of a feedback, although it's not showing here on the scope. Here's the off and on. It's not much change on the green line, but the red line's showing some massive spikes. Very interesting. If I turn this voltage up, increases the spikes, but also changes the frequency. So I'm going to come back over here and try to do this while it's running. So I've got to be very careful not to shock myself. There we go. Smooths it out. Still on. The light's barely bright. There we go. So 6 volts. So we can turn it down. Okay. And there's what the scope looks now with the smoothing capacitor in there. We'll zoom out a little bit. There we go. trigger down. And so it looks much more like a square wave, which is really interesting, considering that we are simply just oscillating this transistor. It's almost a pure square wave. If you can see right there, the frequency is about 339 hertz. We can change the volume right there, it increases it a little bit. Yeah, I was incorrect earlier saying that it was 4,000 hertz. It's actually only about 400 hertz. About 200 now. Still getting a little bit of a spike there. I'll turn it down. And there you go. I'll hook up this, try different setups and different scenarios and see if we can get anything any better. Maybe I'll hook up 2 or 3 light bulbs, see what the maximum output will be. I'm really excited to see what we can get out of this. Talk to you guys later.